Okay, let's see if we can get things a little closer to being mastered this week. And I thought we'd start by taking a look at some of the different homework solutions people sent in, which had really a nice range of approaches and different kinds of style. And I think everyone benefits from seeing that. I also want to make absolute sure that you're all using Debugger and Workbench, because to get through any kind of conceptual challenges or syntax challenges with linked lists, these tools are really going to lend a big hand. So let's start off taking a look at Brian's program, okay? He went ahead and said, look, make me an int node. Remember, in Java, every time you do this, what you get is a reference, a memory address. I think it makes it more confusing than C, where you have a different notation for pointers than for variables, but we are where we are, and it maybe is a little simpler in terms of syntax you're writing. So int node, head, these are memory addresses, okay? This int node here is not an int node itself, it's a pointer to int node memory location. Head is the address of where in memory that int node data is going to reside. So we'll see that when we go to the workbench. Right now, I've just put a debugging point down here, compiled and run with the debugger on, and we've walked through and called the constructor for int node over and over and over. So if we hop over to the debugger window, it says, look, you've got one active variable. If you want to look into that, I'll show you private data and a pointer. Link has reference address in it, a memory address. If I say, well, go there and show me what's there, it says, yeah, another node. It's got data in it and another memory address. So you can, in the debugger, walk through and see the linked list. I think it's a lot more convenient to go into the workbench, say head, and see a drawing of the linked list. Here's the head reference he created in this constructor line with the 15 value down here, and then he kept popping in 56, 62, 22 all the way back to construct a full list. Let's leave that window open, okay? And now back in the debugger, we don't want to step to the next line of the program, because the next line of Brian's program ends. We want to step into his in-between method. Okay, now that's a method that he put into the int node class. It's a public method, so you can head dot in between. It's going to try and start at this pointer. We probably didn't even need to pass that guy in, since we had a self-referencing. We could have self-referenced the object itself here, but so maybe I'd change that, huh, Brian? But it'll print out all of the values in between 10 and 40 in the list. So let's see how. We're going to step into it. So now we have different local variables. Now we have head, x, and y. We're in this block of code. Okay. And this loop is your best friend. Okay. This is the basic construct for moving through any linked list. You want to make absolute sure these symbols are clear to you. And I grant you they're funky. Cursor equals cursor.link. It's not algebraically correct mathematically. It's a programming construct that makes sense to us. So we create a new int node reference, and let's take a look at that. There it is in the drawing of the workbench. There's a new guy in town called cursor. He points the same place head points. Why? Because we just said cursor equals head. Is it null? No, it's not null. It's pointing to this guy. So then let's look at the data. So we step down, yep, we're going to print that one. Now we come back and we're about to do cursor equals cursor.link. Start on the right-hand side, resolve over to the left. So cursor.link, well, cursor's pointing right here. This is cursor.data, this is cursor.link. So cursor.link, this arrow, is going to be the new thing that cursor has as a value. So when we take a step, cursor now points to this node in the same way that head.link points to this node. And that's the basic construct of walking through a linked list. As we keep repeating here, you see cursor moving all the way down. Brian's printing the ones that are in the range, and we leave and come back and end the program.